Now I'm going to revisit a mapping that I talked about earlier. Now when we looked at this mapping earlier, I used A's and B's. Now I'm just going to go ahead and use our more familiar friends, X and Y. So we know our function f is going to take an x value and map it over to a y value, but y is also going to be called f of x. Well, now that we have this way of thinking about this particular mapping, remember that f inverse is going to be the function that undoes this mapping. So f inverse would take this f of x and map it back to x. But now, when you look at this picture, think about what that means in terms of functional notation for our function f inverse. So we have f inverse. The input value for that f inverse is the expression f of x. And where does that input value get sent back to? Gets sent back to x. So f inverse of f of x is equal to x. Now, as you look at this, we have to be kind of careful about this one because it isn't necessarily going to be true for every single x. So we have to make a comment about the fact that it is going to be true for every x that's going to be in the domain of f. So in the domain of f for all x in the domain of f. So we have to make sure that we're starting with an x that could have gone to the function f in the first place. If we don't have an x that could have gone to the function f in the first place, this whole picture falls apart. So f inverse of f of x is going to be x as long as that x was in the domain of f in the first place. Well, we can also come in and say the opposite operation. So instead of having the f inverse on the outside and the f on the inside, we can do the same thing and say, well, let's do f on the outside, f inverse on the inside, and that also is going to be x. But once again, this only makes sense for things that could have started this journey. So for all x in the domain of f inverse. So this is a cool thing to note then, that this is just a different way of saying that f and f inverse undo each other. So we have the f inverse, we have the f, they started at an x, and they ended at that same x. And we can do it the other way around, and it works as well. F of f inverse, they're going to undo each other, and they're going to take this x back to the x that we started with.